Good afternoon, everyone. Very nice to be back here at the conference, albeit on the internet rather than face to face, and fantastic to speaking to so many new people. I am founder of Constructivist. We are working with engineers in academia and in practice to help them develop creative solutions to the climate practice. That is to the climate and ecological emergency. That is front and center of what we are about. And we have a, I would say, underpinning statement in what we do, which is that you only learn when you do difficult things. You only learn when you do difficult things. You can have a nice time doing not difficult things, but learning is about doing things you can't do. And so I think there's a huge amount of learning that needs to be done, both for us as instructors and also for our students. And we need to do that with them. And this transition, this curriculum for the climate emergency is going to be like nothing we've seen already. And so we're going to have to be upfront and honest that we are going to need to be learning. And the way we're going to learn at the same time as them is to ask questions. So in a time of crisis, in a time of change that we're in at the moment, certainty is eroding. And what we know is if we don't do anything about it, the outcomes will be the worst flavor of climate breakdown rather than the least bad flavor that we can hope for. So in that sort of world, you need to be asking questions rather than just referring to or hiding behind the certainties of the past. Now, in 2012, I wrote, on the basis of interview questions with academics, some guidance on how to embed sustainability in the undergraduate curriculum. And that was when I was at my old firm, ThinkUp. I now think that guidance was suitable maybe for the time, but naive now. And we need to be asking some much bigger questions. And so what I'm about to show you now is some of the questions that went into a paper that I wrote with James Norman, which was recently published in the Institution of Structural Engineers, in the Structural Engineer magazine. These are questions which I think we should be asking ourselves, and we should be asking our students. So the first question is, how can we come to terms with the scale of the problem? Now, there is a lot of research that shows that when being presented with doom, with our own impending doom, we'd rather not think about it. Thank you very much. But actually, this is something we need to face up to. It's much easier to say that we are it's much easier to not really think about the scale of the problem than to stay focused on it. But we really, really do. We are 1 year after a lot of work was done to make declarations, but are we 1/10 of the way to solving the problem getting carbon emissions down to 0 by 2030? It's a huge challenge that we should need to be facing, and we need to be asking, are we still focused on it, or are we ducking the question? So we need to think about, how do we come to terms with the scale of the problem? How do we come to terms with the impact? How do we come to terms with the idea that industry and academia, as we understand it now, may not exist in 10 years' time? I mean, this is really fundamentally big questions, these are. And if we're not asking them, and if they're not in the forefront, then we're really ducking the question and having our head in the sand. Second question, how do we re-establish the importance of our ecosystem? It's fascinating that the Victorian definition of a civil engineering involves a statement around working with the forces of nature, but actually, and mastering them, to use the language of the time, what we need to be doing is asking, how can we re-establish the importance of our ecosystem and our dependence on it? The ecosystem is what we come from, it is what we are part of, but I think in a lot of teaching settings, it is almost completely, it's just not there. You can't see it. You can't even see the trees. So actually, we need to be looking and learning and working much more with that ecosystem. How can we bring that in? How can we learn from how nature, which is a usually auto-stable, self-correcting system, how can we build some of those principles into what we're teaching? The third question, and this is really at the heart of the work that I do, which is about how can we drive creative vision? This crisis, as much a crisis of carbon, of climate, is a crisis of vision. It's a crisis of imagination. There's even research that shows that as CO2 concentrations go up in the atmosphere, we are less creative. So actually, we really need to be thinking about not just what shouldn't we be doing, but what could we be creating? As previous speakers have said on this call, on this conference, we actually have the technology right now to meet the outcomes. We have the technology to avoid the worst form of disaster. We don't have to wait for anything new. All that we need is the will. We need the will to imagine the world that we want. We need the will to campaign for it. And we need the will to continue striving for it. So, and there are lots of techniques that we can be teaching here. We can be talking about how to gather creative inputs. We can be looking at how to challenge each other. A model I've been looking at recently is the model from the RSA Future of Work recent report, which looks at how do we learn from a crisis. So in a crisis, there are things that we start doing and there are things that we stop doing. And a question in a crisis is to look at, of the things that we started doing, what should we stop? And of the things that we started doing which were good, what should we amplify? And equally, of the things that we stopped doing in the crisis, what should we let go of? And of the things that we stopped doing in the crisis, what do we need to restart? This applies to COVID, this applies to the climate emergency. And these are creative thinking tools that we need to be bringing to our students. The penultimate question, the fourth question is, how do we promote practical problem solving? I think that we are going to be moving into a phase where we are dealing with unprecedented certainty. So we can't be doing things all from codes. We need to have first principles problem solving. And so we need to be building that problem solving into our teaching. I'm a big advocate of PBL, of problem-based learning as a technique. And I think it's those sorts of techniques where we're having to solve the problems as well as the instructors that are really going to set the students up for solving the problems of the future. And I think that as the sort of previous generation who have got us to where we are so far, I don't think we are necessarily qualified to say what the problems are going to be. I think we should be looking to the next generation to be asking the problems and for us to be confidently working with them to help solve them. The penultimate question is, how can we understand the impact of our work in a broader societal context? Now, a lot of our work as engineers in the UK is fueled by and supports a growth-based economy that has a huge exhaust of carbon. That exhaust of carbon disproportionately damages and has impact on the global south. This is actually a structurally racist problem. This means that our work, and if we say we don't care about it, that is structurally racist, because it is saying that our work has impact on other people's lives that are far away and it doesn't affect it. It doesn't matter to us. If that is fundamentally wrong, we need to start changing that. We need to start having a conversation in universities about that. And finally, how often should we consider the climate emergency? And my answer to that is it needs to be at each phase of what we are teaching. It needs to be the context. We need to be asking, how is this relevant? And how is it preparing us? And how is it preparing our students for dealing with it? So those are the questions. I think that they are a way of actually developing us, both as teachers, as well as the students themselves. Just as a brief plug for this kind of thing, we are working with academics and organisations at Constructivist to help them figure out what to do in a climate emergency. And we run some training called Training on What to Do After Declaring a Climate Emergency. Got another round of that starting in October. We've had academics on that course, and as a result of attending it, they have made significant changes to their curriculum. So I do recommend it to you. And also, to pick up on the comment made earlier on, I'm one of the coordinators for XR Engineers. So if anybody is interested in finding out about how we're trying to engage with the emergency and support engineers to take action, both inside and outside the profession, then do get in touch. Thank you very much.
Thanks, Catherine, and thank you very much for the opportunity and privilege to talk to you all today. My name is Emma Crichton, and I'm a chartered civil engineer with 6 years experience working in the water sector in Scotland. In 2016, I volunteered to be part of a carbon team alongside my day-to-day role as a lead civil design engineer, where we created a decision-making tool to consider carbon at all stages of design. That was then adopted by Scottish Water and rolled out across their business, including over a £1 billion programme of work. I now work at Engineers Without Borders UK as the head of engineering, and I've come to realise that tools alone cannot improve outcomes. Looking at carbon alone is not enough. We need to embed global responsibility into how engineering is both taught and practiced, and this is what I'm here to talk to you about today. So let's have a look at that big picture once more. It's widely accepted that the way we currently live on the planet is not sustainable, nor is it equitable. Therefore, how we've been doing things needs to change if we want planet Earth and the human species to thrive into the future. We have no planet B and time is running out. Evidence has shown that we really need to get cracking on tackling the issue at hand. So let's look at this a little further. The world faces twin challenges: delivering a decent standard of living for everyone while living within our ecological limits. These two concerns are brought together in Kate Raworth's donut economic model, which visualizes a space between planetary boundaries and a social foundation where it's ecologically safe and socially just for humanity to exist. Social foundations are broadly drawn from the UN Sustainable Development Goals, and the ecological ceiling is drawn from the 9 key areas verified by the scientific community with the Stockholm University Resilience Centre. The areas in red is where we're either not meeting the needs of people or where we are pushing our ecological limits as a planet. This diagram helps to articulate and evidence that there is a problem. And for those that would like to look more closely at the UK, Oxfam have used the donut model to provide a snapshot of the UK's status by presenting a similar framework and for incorporation into a national kind of UK analysis. I hope when you look at this model, and given the conversation that we've had already today, you can see how engineering can impact each area. Engineering has always played a key role in human development and the impact we have on the planet, both positive and negative. It is widely accepted that the way we currently live on the planet is not sustainable, nor is it equitable. And if we're designing our future or our present, we should be placing increasing importance on addressing this. How we've been doing things in engineering needs to change if we want planet Earth and the human species to thrive into the future. For those that are interested, we discussed this model a little further on our latest news article on our Engineers Without Borders UK website, which Kate Raworth has actually just retweeted today. But kind of to pick up on some of the points that Tim mentioned, especially around the intended learning outcomes, if we need change, what needs to change? So for us, global responsibility in engineering is about refocusing the engineering mindset and skill set on ensuring engineering serves all people and the planet better than ever before. We need to understand that to tackle any of our sustainable development goals, we must consider that they're very much interconnected and actually look at what mindset and skill set is required. We also need to question the things we're taught. Engineers are problem solvers. I've heard this throughout my education and still most days working in engineering. And this needs to be reworked to recognise the importance that engineering changes the way we live and recognise that there are both positive and negative impacts. This has been discussed earlier today, but if we need this shift in mindset and skill set, we do need to look quite closely at our educational system and how it responds to the needs of the present and future societies. And to provide another example on this, let's take a step back in time and review a mechanical engineering syllabus. On the left, we've got MIT's syllabus from the early 1900s. Steam engineering, thermodynamics, boilers, theory of elasticity, heating and ventilation, how to design things or products. Industrial Revolution, boilers were blowing up, let's teach that. This demonstrates that at that point, the engineering syllabus was responding to some of the needs of society. In the middle is the syllabus from the 1975, where you see the formalization of the degrees, where science and theoretical principles are used to provide solutions to problems. If you know these things, you'll be able to design in that space. And the issue with this is this curriculum looks familiar to many engineers educated in the 70s, 80s, 90s, early 2000s and 2010s. It's really been stuck in that space since about the 1950s, 1970s. It used to evolve with the perceived needs, but now as the approach with these theoretical principles, you'll be able to design what you need for the needs of people. But our global challenges, like the climate emergency, like inequality, like lack of biodiversity, we need, or how to respond to a global pandemic. Those type of skills cannot just be derived from theory. We need practice. We need understanding how you can do those things, and different mindsets and skill sets need to be incorporated into the curriculum. And it's not as if we don't have an understanding of what needs to be done, but rather the needs of society are becoming more holistic and more than just a simple, what is the next technological advancement? As the Global Capacity Review from the Royal Academy of Engineering states this year, we need to focus on the quality of education. And things are changing, but they need to change faster as well. Ruth Graham articulates in her report from MIT, from the Global State of the Art in Engineering Education, that there'll be a trend towards socially relevant, outward-facing engineering curriculum. Engineering curriculum that emphasises student choice and multidisciplinary learning and societal impact, coupled with a breadth of students' experience outside the classroom, outside of traditional engineering disciplines and across the world. And this is the space in which we work. Engineers Without Borders UK collaborates with universities to deliver effective teaching methods that meet new learning outcomes, because we realise that there is a need to provide options to help transform curriculum. At universities, we run design challenges and critically inside curriculum, and we collaborate with academics around the world to ensure that they can experiment with new ways to improve or adapt their existing curriculum. And as I mentioned previously, we believe in practice, the need for students to practice before their actions have real-world consequences. Similar to how a surgeon would train students practice before performing surgery on a person. This is our approach. We need engineering students to practice first before they are responsible for real-world impact. So to provide a quick overview, we provide real-world educational resources and training and support for academics to run project-based learning. We spend a lot of time, around 6 months each year, working with other NGOs and partners to enhance these educational resources. We provide educational resources for academics and students to use each year, providing detail of a community in a different part of the world. This helps students navigate the unknown, what should we do, what is the brief, how do we devise a problem, and what should we work on, and kind of questioning the space around, what is an important thing to work on, and how to do that. So we describe the key engineering areas of a place, and then also provide a detailed description of the ecological, social, cultural context. And these resources and academics who facilitate that learning enable students to learn about how to do this and have the opportunity to practice. And one thing that I'm really excited about is that our design challenges provide that practical option for academics to be confident to change their modules to meet new learning outcomes, including the list that Tim set out earlier today. So we have almost 50 universities that have these design challenges in their curriculum, and the countries where these universities are based is currently on the screen. But what excites me about this is the network of academics with practical hands-on experience of new teaching methods. And we're also equally excited about the wider movement and the influence that we can have to transform curriculum around the world. The International Engineering Alliance and the World Federation of Engineering Organizations has recently been consulting on the Graduate Attributes and Professional Competencies Framework for engineers. Together with our Engineers Without Borders cousins in Australia, Brazil, Canada, India, the Philippines and the USA, we've put together a response celebrating the changes, but also asking for a central focus on the primary purpose of engineering being to benefit all people and planet. We have also asked that they extend the consultation deadline so that it could be more inclusive and more voices could be heard. So they've now extended to the 30th of November. So if you haven't responded to this, we highly recommend you do. And we're very happy to share a response that we've produced internationally, which you're free to use or amend as such. I think when we look at what we've discussed today, and a final word from one of our academics who talks about uncertainty, the only thing we really know about the future is it's going to be unpredictable. We need to educate engineers who can cope with that unpredictability. They need to be able to work with technical uncertainty and in a changing political context. They need to be able to communicate effectively at the right levels to move things forward in a positive manner and support global development. The Engineering for People Design Challenge encourages a more diverse cohort of students. That means different conversations, different perspectives and solutions that are better for everyone. It's only when we're working together that the best ideas happen. And finally today, I just wanted to talk about the engineering process as well and the various stages required to take an idea through to something that's going to be implemented. At an early stage where you have that blank piece of paper, there's so much influence about what can be done. Rarely anything is said, but having accurate information to back up decisions is hard. So you have low level of accuracy, and naturally so. There's so many options, and reliance on assumptions, judgment plays a critical role here. This is why we need engineering students to practice, to collaborate with various people to make projects meaningful and to understand the importance of this space that is the upfront of your detailed drawings, your specifications, and before a spade is even lifted to dig into a construction site. This ability to influence is key. So as a takeaway, if there's any takeaways from today, so how to adopt effective teaching methods to deliver new outcomes, kind of stuff that comes to mind would be collaborate first, prioritize building partnerships to help improve those outcomes, project-based, so student-led, multidisciplinary, open-ended, relevant and inspire. We've talked about the importance of having engineers go into the profession once they leave university, so having something that's socially relevant and outward-facing, and invest in diverse partnerships, so expand curriculum with those who genuinely see the importance of this. And finally, remember why. We're moving into the decade of action, and we need to act now because the future is in our hands, and at the moment we're deciding what that future will look like. Thank you very much.
Thank you. Mike Cook invited me with the brief of building a bridge between academy and practice. And rather than show you a Brunel bridge, I thought I'd show you a bridge that looks like this. I'm going to be as circumspect and respectful of what everybody has said, and also of the brief I've been given, but I wanted to make a very quick noticed let's call it a provocation of why I do what I do. 25 years ago when we started AKT, which is my engineering practice, and I'm largely a practitioner, what I noticed very quickly was, one, the compartmentalization in the disciplines, and also at the same time I started teaching at the Architectural Association because none of the engineering schools thought Asian people of color could teach anything. So we were 25 years ago starting from that position. So I did very well. And the second thing I noticed was not only that, but the wide gap between what academics and practitioners do and the society we provide for is even bigger. So there's a much bigger bridge to build together between practice and academia, right across to what it is we're supposed to do. I won't apologize it, but others have already filled us up with cliches and contradictions. And I'm going to do some more of that, if you can allow me. What I chose to do was really show you maybe a small number of examples only from my academic work, rather than a show and tell on the practice, and then some of the work of the colleagues. The first one, responding to the President's and Mike's idea about climate, was under the theme of what is zero carbon. I wanted to start with an extreme. It is not new, as Tim Abel already said, and others. 15 years ago, I was fortunate enough to be teaching and understanding the complexity. So part of the research that happened at the transdisciplinary concept, I need to say that because I teach at Harvard as an engineer, not as a designer necessarily. And to be relevant and authoritative as a practitioner is something that is contingent on how we teach over there. Therefore, a project like this, for example, is relevant as in it was a piece of research funded by a state in the Emirates to try and figure out zero carbon in the desert, which is a paradox, we all know, and there's a lot of criticism of this project, but I can tell you that it was started completely at a school as a conversation. It also said something slightly important, speaking to what everyone else has said. The bottom right shows you the kind of history of what's going on in that region, what's been there for millions of years, thousands of years. So one thing to say right away, there is very little new going to come out of this conference or anything we plan to do. Look back at history and try and work from that. So that was a starting point for us. We were fortunate enough then with Foster and Partners to win the first neighborhood and go on and build it to prove the research. And the top left hand is probably the only real diagram I want to show you, because you might not be able to read it, but in a typical Abu Dhabi street, which you see on the left, compared to the Mazda neighborhood we've built, the post-occupancy temperatures vary at the same time, in the same conditions, by up to 10 degrees C. So zero carbon to a point, or at least the savings that we're making in the global south from this kind of project, from actually studying the history and then using the new tools, but most importantly, having the leading designers, not engineers only, who can actually go back and measure success and failure and publish it. So that's point number one. The second point under that same theme is that you can't just do it once. We've learned that you have to keep doing things over and over. So last year, we brought that zero carbon agenda to central London, a developed world where the problems are different. And at Canada Water, we ran a studio. So Harvard ran a studio with me as the principal investigator on it. And you see a little bit of what the agenda was. Canada Water, which is the next version of King's Cross, British Land, supported this piece of research. Basically, we took the idea of what has happened over 4,000 years of construction in London, and you come to a very quick conclusion from an architect's position that buildings are continuously recycled, reused, program and functions proven to be both inappropriate and drive a form or a place. So all of the stuff that we were talking about in terms of reuse and adaptation is hardly new. But how could we fast forward it and do it in a very compressed way? So we brought 14 students for 4 months who lived in our practice, in our office, to look at the Exquisite Corpse. What you're looking at the top left-hand side, most of you will understand. We gave each of them a plot in a car park, and we set them off for 16 weeks to go and design a building. But they were forced on a every 2-day basis to present a physical model of what they were designing, and they were told they can't speak to the neighbors, which is how cities work. So they weren't allowed to speak with each other. You're seeing some of the images of the conclusion here. The models then, you might just see them here. At the end of the process, what they got to do really 1 week before the final, which is 16 weeks in, with a lot of critiques and a lot of London people who are working in how to make the city, was we managed to put them all together. And then at the last week, they were allowed to negotiate something. So this was a very fast version of doing 4,000 years in about 16 weeks, but using the latest tools in order to understand what interdisciplinary connection means, what the role of a structural engineer is in that, what are the questions it raises, not the answers it provides. Most good engineers can give a lot of answers. They sometimes just don't know what the question is. Along that line, the second theme I put together was embedding in a circular economy. And I wanted to show you 2 examples of that research and work. So this is exactly what Mike asked for. What is the bridge between what we teach and what we are doing as practitioners, and then the third bridge to industry. This is a project or a course I've done for 10 years, every 1 semester, every year. And it is deliberately forced to work across campus. So we have anthropologists, structural engineers from MIT, architects, all sorts of people in the room. And we run a semester-long discussion and then publish the conversations. But they are doing case studies and end up doing a project. So the interdisciplinarity of this is very different from what is perceived or what is sold off as multidisciplinary practices. There is a very detailed specialist conversation by each of the experts, and it's the joining up where things go wrong usually. In the same vein, when I was doing this work, I was also fortunate enough to be a CABE, Commission for Architectural Built Environment Commissioner. Somebody there noticed that I happened to be an engineer, which was very useful for the Institute of Structural Engineers, although I don't think they ever mentioned it to me, but there you go. CABE invited me as a commissioner, and I was looking at waste to energy plants for quite a long time for the government, because we were going to build 17 of those. And we did a 3-year piece of work comparing Sweden with the USA, just the idea of actually avoiding landfill in the USA. That led to a lot of work, and there's a book published called Architecture and Waste. I'm not selling the book. It's probably sold out by now because there weren't many published. But the point I'm making is this was a 3-year piece of research across disciplines with me as the PI, across practice as well. But what's really wonderful about it is halfway through that process, we were fortunate enough to be invited to a competition with Bjarke Ingels architects in Copenhagen to rethink a waste-to-energy plant. And the only thing we were given is the 20% that the engineers haven't done. So whenever one of these is built, 80% is photocopies by practices of the last time they built one of these. So the only opportunity really for research, design, and education was what can we do the facade? What is the new question we could ask? And sticking to the circular economy, how can we make waste as a kind of something to benefit from, something that you want in your neighborhood? And we obviously put a ski slope on it. You probably have seen it in TV adverts and so on. The rest is history. The point about this is the value it added is many people want to live around here because they have access to this. House prices have actually gone up. Most of the UK, nobody wants to live near a waste plant. So I think there are skewed questions that we're answering through research, and I'm doing very fast discussions on this. The third group that I wanted to present very quickly was extremes of environment. You know, we talk about climate, and for the last 10 years, as I told you, we've been doing both in the practice and over there, some things that others sometimes find difficult to frame as a question. So one of the questions we framed was what are typical extreme environments? And I just show you what came out of that. One of the things we decided to do in Ljubljana with office architects as a collaboration was run a semester-long studio that would try and put a shelter on top of this mountain that a lot of people climb. Is near Lake Bled, an incredible place, but there were risks in that it gets very cold very quickly at the top, and there were deaths quite often. So we built something and lifted it in with a helicopter, but part of the research was that we would use drones to lift in lightweight timber, which most engineers know is easy to pick up. I just say it because sometimes things don't go right. At the last moment, the drones were pulled because they were quite expensive. The sponsor pulled away. And the only thing we were left with, really, because our students already designed this and we'd already made it on the ground, was to ask the army to help us. So there's an entrepreneurial edge to some of this work that I wanted to mention. Continuing along that kind of other project types, the material research is quite interesting because there's so much noise around it from engineers, but in particular engineers actually. The way I completely think about it, which I think my colleagues have said, is there is very little new. In what we do as structural engineers, the 5 materials we use will be here for the next 1,000 years. How are we going to overcome and try and deal with the targets we're now setting ourselves? Well, one of the answers has become cross-laminated timber. And sadly, I got frustrated with my practice looking at how this was being hived off as a new specialism that can only be done by real experts in timber. So I thought I'd just ask a few students to do it instead, just to make a demo on it. And what we did is really set us a task with a Swedish, they're very amicable and very helpful when it comes to sponsoring. So Martensons in northern Sweden collaborated with us so that we could take the students to the factory to demystify what CLT is and what are the engineering properties, and then run a studio for 16 weeks to look at 2 scales. One is what is the tallest tower you could do, and it's only the tallest one at the moment is 70 meters in Skellefteå, so we picked that as our place. And we picked the south of America in the Carolina area, where there are new factories developing with timber, as our site. And we did 2 things. One was a tower, and the other was a house. So when it comes to this third topic of doing extreme things or doing, material research in that interdisciplinary environment, I think I'm very fortunate to be associated with 2 leading institutions, one being Harvard and the other one, the engineering office I work with. And we try to get into a position where we have, as somebody said earlier, we're looking at failure. So quite often there is an addiction to taking risks to try and do something like this in 16 weeks. So that's the message that I want to leave you with, but I want to show you or share at least the works of colleagues at Harvard. So this is people I'm surrounded by. The Kumbh Mela, Professor Rahul Mehta in urban design in 2019 took these disciplines. So all of the schools, from the business school, the School of Public Health, the School of Design, which I'm part of, Divinity School and the School of Engineering, for 3 months across to the Kumbh Mela. For those who don't know, this is an ephemeral city. 100 million people every 12 years gather there for about 3 months. Now, this is better than the Olympics. There's no money either. There's no corruption hardly. So you get to build the city, including the sewage, the cemetery, everything. So that's the level at which you cannot exist in that environment as an engineer unless you have confidence in your own and expertise in your own field. So you can actually do this cross-disciplinary or pan-disciplinary conversation and make a valuable contribution. Again, most of these things are published for anybody who's introduced. Rahul Mehta's book is out on this subject. We had medics there, so the spread of disease was one of the discussions that they went through. There's a lot to learn from this kind of stuff that I believe engineering schools keep away from largely. The other colleague that I want to talk about specifically is Professor Ali Makawi, who is our head of the Green Building. So it's the Harvard Center for Green Buildings and Cities. We've taken one of our houses, which is a campus house behind the Gund Hall, where the architecture school is, and he's completely fitted it out over the last 3 years, Snow Tower, the architect, to really find out what big data can do for us. So with a lot of sensors, I mean literally millions of sensors, so we can understand each move based on data and use computation the way it should be used to measure outcome, output, and value that's being added to a typical house type in that climate in Boston. So the work is continuing, and it's been sponsored in a very large scale in a way. And I think the results are going to start feeding out in the next year or two. The center opened last year. The last one that I'd like to share is Professor Martin Bechtold, who is the Professor for Technology. I'm the visiting professor of technology there. The Masters in Design Engineering is a program that we collectively spent 4 years developing a curriculum for, because we saw a massive gap or a large absence really in some of the new questions that were being raised by cities, clients, and people. And we spotted that these weren't going to be answered by economists, architects, or engineers. There's a new type developing usually they have 2 or 3 degrees, the kids who get onto this kind of course. But the Masters in Design Engineering now has been running for, I think 3 cohorts have been through it. And even during the COVID times, it's oversubscribed. I think for every place that we have 180 capable applicants who want to get in. It's an 18-month to 2-year course, recommended if you can afford to go. It ain't cheap. My last slide really is based on the brief, because when I was asked to do this and told that you won't be seeing me, what came to my head was, we're remote as it is. Isn't it bizarre that we are working on a platform where you don't even want to see who's speaking to you? I think this is something that bothers me, because I don't know where these conferences end up and who's listening to what. The ultimate thing to me that I think is the responsible thing to do, if as the president said, we need to talk to the global audience, we need to be cautious about thin slicing. So I'm all for adaptive reuse and refurbishment, but as was said earlier, this is not relevant in the global south, people. I have a practice that has 10 people and under in teams, so whilst I'm not an SME, it's relevant for a lot of the adaptive reuse we're doing. But we need to think broader, because the structural engineering industry in the UK is highly respected all over the world. Historically, largely speaking, okay, it's always been middle-aged white men who managed to get out there and speak about it. Largely speaking, we are still respected, and I think we have a bigger role to play. So this project is a conclusion to my presentation, is done for the next generations. In Sharjah, it was literally called the Pavilions for the Next Generation by the Royal College of Art. We were invited and we worked with cooking sections, or a small multidisciplinary young team, to try and devise a small garden where desert plants could grow without water. Don't forget, I'm an engineer, a structural engineer, but the kind of question these people were asking us was so intriguing for the global south that we thought, how can you say no? And we've got involved, and we've put all that kit that you see in the bottom right. We're measuring how this will work, but it's the kind of thing that I hope people who are listening, I know that part of the world is listening to what I have to say. I also am conscious of social tourism that goes on in these places. So we are very confident that by bringing a bridge between academy and real practice and building stuff, we can be measured by our failures and successes and still continue to deliver the targets that we have set ourselves as a society. So I leave you with that provocation. Don't thin slice the institution even more. Please, structural engineers, don't do it. We're all good at all of these things. You can all design timber. You can all do adaptive reuse if you passed your struts. That's me. Thank you.
I'm sure we'll have plenty of questions, so I will go straight into those. Okay, so I'll start with a question that we have for Oliver, if you're listening, Oliver. So there's lots to think about in your own presentation, but if you could only do one thing, what would it be?
I think it is a human trait to avoid the big question. So I think always be asking, what is the big question that we are avoiding in our teaching? And you can ask the question of your students, and you can ask the students to ask the question of you as an instructor, but just keep going back to what is the big question that we're avoiding. That's it.
Okay, easy peasy. Thanks. Easy said, at least. And Emma, question for you also. How can I find out more about the design challenges that you spoke about today?
By either contacting us via our website, so on Engineers Without Borders UK website. Yeah, there's lots of information on there to find out more.
Okay, perfect, great, thank you. Hanif, I have one final question for you, at this point at least, which is as a practicing engineer with quite a large firm here in the UK and a lot of structural engineers, I wonder what it is that you feel graduates need to be able to do and should be able to do well in order to survive and excel in the current, design office marketplace, if you want to call it that. And how important, in all honesty, is the climate change agenda to these things, to these aspects?
Answer in reverse. The climate change agenda is undeniable, and you cannot get away from it. But when you look back in history, let's not choose climate change, but let's talk about pandemic for a second. When we last had the pandemic, what happened afterwards was that 200 years later, institutions changed, professions were invented, all sorts of changes can come out of these problems. The issue with the climate change, really, it shouldn't be forgotten. I do feel quite strongly that we as engineers can contribute by having a bigger conversation and being represented in the politics of that world, not only in the engineering of that world. And I say this with great confidence from the Royal Academy of Engineering's perspective in particular. But what I see in the US and what I see at Harvard, despite what CNN tells you, is there are some big thinkers around who are trying to get involved in how to actually do some really good research. So when it goes to graduate level, get a technical competency immediately on how to make buildings stand up. That is very simple. as somebody said earlier, that isn't too complicated. You just have to get through your structures, but then, embrace that career. I've been in it for 40 years, and I'm sure my colleagues will agree. There is so much fun and so much good you can do that you need to then start thinking about all the other questions you could answer or set up for other people. So collaborate with other institutions, collaborate with other graduates as often as you can, even if you're working from one office that doesn't have all of the other disciplines within it.